VLSos here. This is a video lesson on inverse trig. We're going to begin with a familiar equation. The sine of theta is equal to y. And typically we would have or choose values of theta and use the equation to calculate y. And if we plotted those points, we would be graphing a sine curve, a sinusoidal wave. But what if it's y that we know and we wanted to find theta? For example, what if we had sine theta is equal to radical 2 over 2 and it's theta that we wanted to find? Following the rules of algebra, we want to solve for theta. We want to get theta by itself by undoing sine with its inverse. We're not going to divide because sine isn't multiplying theta. Sine is its own function, and the inverse of sine is literally called inverse sine. Showing our work, we would take the inverse sine of the sine of theta. These would undo each other. They're inverse functions, and it leaves theta by itself. On the other side, what we do to one side we must do to the other, so we have to take the inverse sine of radical 2 over 2. Well, what's that? It's a value. We could find it in a calculator, but calculators are limited. And to see why, let's first approach this with our understanding of the unit circle. So if we had a circle with a radius of 1, and we were looking for an angle whose sine value or y-coordinate of the intersected point is radical 2 over 2, and we would be looking for this angle here. We could label theta. The sine of theta is equal to radical 2 over 2. What's theta? Looking or being familiar with a unit circle might help. This is a common angle. And in this case, the common angle that has a sine of radical 2 over 2 is pi over 4. But in seeing it this way and being reminded of the unit circle, we know that there's a second point that has the same y value or the same sine. And this second angle is not the same as theta, but it shares a relationship with theta. It's the angle in the second quadrant that's found by taking theta away from a half circle, or pi minus theta. And that second angle is 3 pi over 4. It's uncommon to have the sine and cosine values of common angles memorized, so using a calculator is often necessary. But a calculator is only going to give you this first angle as an answer, though you may need to have all of the answers, all of the angles whose sine is radical 2 over 2. And these two angles are only the two that are in a single circle. There's an infinite number of angles that have a sine of radical 2 over 2 if you take any one of these two angles and add or subtract full circles. So why is a calculator limited? Well, this function, inverse sine, is its own function, often has its own calculator key, and when you use it, the calculator is thinking of it as a function, and it gives you the answer when you key it in. But remember, for things to be functions, they have to have one-to-one correspondence. And this function here, if we were to graph it, doesn't have one-to-one correspondence unless we limit its range. To understand that, let's consider graphing inverse sine. We're going to find the graph of inverse sine as a reflection over the line y equals x, starting with the sine function. I'm going to choose my intervals and label this 1. So when I graph sine, which starts at the origin, sine is going to reach a maximum at pi over 2, which is approximately here. So this is going to look stretched out a little bit. And finding the inverse of this sine wave graphically will be its reflection over the line y equals x, a line through the origin with a slope of 1. And if we can visualize reflecting, it's going to look approximately like this. Here's the issue with inverse sine. Because sine is periodic and has multiple solutions, when you reflect it, its periodic nature means that it will not pass the vertical line test. If you reflect the entire wave, then any vertical line is going to intersect at an infinite number of places. To consider the inverse sine to be a function, we have to restrict its range only between these 2 points. It's a curve. And if we restrict the range, then what's left will have one-to-one correspondence. Now in making the inverse, we swapped the horizontal and vertical axis. So what was the theta axis is now y, and what was y is now theta. And we can use inverse sine as a function this way. That means that if we start with a y value of radical 2 over 2, which is approximately here, then we'd be able to use the function and find the value at this place, which would be a theta or angle value of pi over 4. Where's the second angle value of 3 pi over 4? It's outside the range that has been defined for this function. It would be somewhere up here, and we can't see it because the wave would have to come, the wave that was reflected would have to come back, and we can't because then we would be breaking the rule of one-to-one correspondence. So calculators are limited because they think of inverse sine as functions. It's the human mind that can understand that if you're undoing sine to try to solve for theta, calculator can give you the first, but you have to use the concepts to find the multiple or the other angles that are possible.